I'll have to teach you P5 from the beginning right now. Okay, now, as you know, your A2 has P4 and P5. Now, P4, your total marks is out of 130 points. P5 is out of 30 points. Okay, and then in terms of the duration of the exams, for P4 is actually just 2 hours. It's 2 hours. Wait, no, sorry. It's 2 hours. Whereas for your P5, it's actually quite short at 1 hour and 15 minutes. All right. So P5 usually consists of 2 questions, question 1 and question 2. Now, question 1 is where you have to design an experiment. You have to describe how you want to do your experiment. This one is the experimental design question. Then question 2 is more on graph and error analysis. Okay, so this one is the basic structure of your paper 5. Question 1 is 15 points. Question 2 is also 15 points. All right. Now, when it comes to question 1 would be kind of like a hit or miss thing. It depends on your luck, because the thing here is that they usually will describe some sort of situation to you, and then based on your physics knowledge and common sense, you're supposed to describe an experiment out of it. So for some students, certain situations, certain questions that were given to them, they don't really know how to do it. And then for some other students, the situation that's described to them, they know how to do it. So it's kind of like depending on your luck, whether you're able to do the questions really well. Okay. But the thing is that for question 1, it is very format specific. There will always be a few key basic things that they look for. And those few key basic things are the ones that students normally will be able to score, regardless of whether they actually know the experiment or not. So you know the formatting for question 1, you will easily be able to score at least 7 points. In the worst case scenario, if you totally just do not know how to do the experiment, if you know the formatting and you just write your answers based on the format, you will get at least 7 points, at least half from there. Okay. And then question 2 is more on your graph and error analysis, where they'll give you some values inside a table, and then you're supposed to plot the graph, find the gradient, do some calculations, and then finally answer it. It's a bit like your paper 3, question 1, when, you know, last time in paper 3, question 1, you do the experiment, you do your tabulation, plot the graph, calculate gradient, calculate y-intercept, and then calculate the constant. It is quite similar here for question 2, just that it has been expanded. Okay, so usually question 2 is where most students will be able to score at least 13 points and above, because it is very, how to say, it's like doing maths. If you done enough, I mean, like when you're doing maths, you know that if you do enough of the questions, you will intuitively develop some sort of sense on what to do when given certain questions, right? So it is somewhat similar here. There's nothing to really describe in question 2. It's more just on calculations. So if you know how the calculations go about, usually most students will be able to score more than 13 points here. Okay. So, and then in general, for paper 5, for an A or A star, usually we would recommend students get at least 20 and above. Okay, now maybe I will write this. A should be 20 and above. A star should be 25 and above. Okay, so this is what we are looking at. All right. Okay, so let's just start with your question 1. Okay. All right. I sent you 2 paper files earlier, so I'm just gonna have a look at March 2021 P52. Okay, this is the March paper, right? So for the March paper, let's just look at this one. Okay, so let me zoom out from here. Okay, right now, usually from the beginning of your question 1, they will describe some sort of situation. Okay, and they'll give you some equation, as you see here. A student investigates the vertical oscillations of a solid cylinder which floats in cooking oil. The figure below shows a cylinder of radius r. The student places the cylinder of mass m in the oil. The cylinder is displaced vertically from its equilibrium position and then released so that it oscillates. The period t of oscillations is then determined. A number of cylinders of different masses are available. it is suggested that the relationship between T and M is actually given by this equation, where sigma is the density of the oil and K is a constant. From here, you're supposed to design a laboratory experiment to test the relationship between T and M, and then explain how your results could be used to determine the value of K. So in your diagram on page 3, show arrangement of your equipment. In your account, you should pay particular attention to the procedures to be followed, measurements to be taken, control of variables, analysis of your data, and safety precautions to be taken. Okay, and then you look at the next page, is basically a whole blank piece of paper. If you haven't write your answer, you're supposed to write your answers and give some diagram describing how you're going to conduct experiments following the instruction given. So here, usually a common thing that you will notice inside your question is this. They will give you the situation, they will give you an equation, and then they'll tell you specifically what relationship are they really testing, what variable are they testing the relationship. Here, in your case, they're testing the relationship between variable t and variable m. And then after that, they will subsequently also ask you, how are you going to use your results to find out a value of some sort of constant? Okay, so these are the main two questions usually you are supposed to answer based on the situation that's described. Now, generally speaking, to test relationship between two variables, this one, you will need to plot a graph. You need to plot a graph to test the relationship between two variables. You will need to plot a graph based on the equation given.
Yeah.
You will need to plot a graph based on the equation given. Then what will tell you is that the relationship will be valid. Relationship is valid if the graph plotted follows the shape expected from the equation. Okay, so this is generally what will happen when we ask you to test relationship between two variables. You will need to plot a graph based on a given equation, which is in your case this one. And then from there, we will actually say that the relationship that you're testing will be valid if the graph plotted follows the shape expected from the equation. So when it comes to graph plotting, I could give you a few examples. If I tell you that your graph in general looks like this, y is equals to, say, kx squared. If I ask you to plot a graph of, say, y versus x, you would say that it looks like a quadratic equation just like this.
Yeah.
Now, if I give you y equals to mx plus c,
straight line,
it will be a straight line. So you plot a graph of, say, y versus c right now, so y versus x right now, you by right should be getting something like this. Okay, a straight line. Okay, that is what we mean by you need to see whether your graph plotted follows the shape expected from the given equation. If let's say your given equation here somehow implies a quadratic equation, you plot the graph, it should tell you that if you plot the graph based on your results, it should give you a quadratic equation. It should give you a quadratic graph. And then likewise, if your given equation is suggesting a straight line graph, if you go and get your results and then plot the actual graph, you should be getting a straight line. So that is what we mean by this. Okay. Right.
Okay.
So most of the time in your questions for paper 5, they will really only use one type of equation. Okay, they will almost always use a straight line equation. Okay, the graph shape that they always expect to see through your given equation is always going to be a straight line. There will never be curves. Okay, it will always be a straight line. So from there. Okay, so like in my case, usually before I want to start the so now right now if I want to test the relationship, I know I have to plot a graph. And you know that when you usually want to plot a graph, there's usually a value on the y-axis and a value on the x-axis. So the y value axis is what we normally would term as the dependent variable.
Okay.
Okay. And then the x-axis value will be what we term as the independent variable. Okay. The independent variable is the variable that you can actually change inside your experiment. This is the one that you will purposely, intentionally change. Then the dependent variable is what you actually want to measure. It is the thing that will change according to what you manipulated in the first place for the independent variable. So for example, I can tell you, I give you a simple equation. F is equals to kx. I know that if I plot a graph of say f versus x, it's going to give me a straight line. But when I want to do the experiment to go and plot this graph, what you know is that you actually need to manipulate certain things and then after that measure the resulting change as a result of what you did. So in my case, if let's just say I am trying to do an experiment to measure the force and extension of a spring, of a load that is attached to a spring, I know I would have to measure force, I will have to measure the extension. But which of these two is the thing that will actually change during the
Force.
it will be force, right? So this one will be F, no? It will be F1, it will be F2, and there will be F3 and so on. So the corresponding extension is what you would actually try to find out over here. Then after that, you plot your graph, you compare with the graph with the equation, and then see whether it is corresponding to the expected graph shape. Okay, so here you are trying to do something similar. So for whatever given equation that you have, the first thing you will need to do is always to identify the independent and dependent variable. Okay. So there was also two separate pieces of notes that I gave you. This is kind of like the summary of question 1 and question 2. So it's actually listed in order here. So for question 1, normally what you would do is that you need to first identify what is your independent and dependent variable. Okay?
Yep.
So that you can know what is actually supposed to be y, what is supposed to be x. So you look at your question right now, the situation that's been described to you right now, they already given you a particular equation, which is t is equals to square root pi m over sigma kr squared. And they tell you that they want to test relationship between t and m. One of this will be dependent, one of this will be independent.
Yeah, so M is independent.
Yes,
And
correct.
then T is dependent.
Yep. Okay, so m will be your independent. This one should be your x. Then t would be your dependent. This one will be your y. So then what's left here is for you to rearrange this given equation in the form of y equals to mx plus c. Okay. So now, if you already know that your dependent is y, going to be the y-axis value, this equation is already giving you t as y. Okay. Then after that, your independent will be your m. So what you need to do is that you need to kind of like change it around so that it is equals to y equals to mx plus c. So what you can do here is that you see this one, the given equation, you square it, and then eventually you get this form. T squared is equals to 4 pi over sigma kr squared times m. So this one would actually be equivalent to y equals to mx plus c, where you see your y-axis is t squared, your x-axis is actually m, and then your gradient is 4 pi over sigma kr squared. Okay, so this one it will tell you quite a number of things. Now, from here, what you will need to say that, okay, what kind of graph should I plot? I need to plot a graph of t squared against m. And if the relationship that's described here is actually valid and correct, I actually would expect to see a straight line graph that passes through the origin. Okay, there's no y-intercept here. Okay, and then finally, if you wanted to find out the gradient, it is actually 4 pi over sigma kr squared, from which you can actually find out what is actually k. You are now answering the second part of the question too. Okay, so this is the first few basic things that I would normally suggest a student to do. Find out what is it that you want to measure, what is it that you want to manipulate. That one would help you to proceed with your question. Okay, so you need to identify your independent and dependent variables in the first place. And then the next step in your questions, you will need to actually do something else. You will actually need to identify what are the variables that you need to keep constant here in the first place. Okay, because your graph here, because for your question here, you are strictly investigating the relationship between t and m. Okay, you're changing the mass, and then after that investigating the effect on the period. But there are other things that could also affect the period, not just the mass. So like in my case, if I look carefully at the given equation here, T can be affected by the mass, it can be affected by the density sigma, it can be affected by the radius r of the cylinder. So not only can T be affected by M, it can also be affected by two other variables. So you do not want the other two variables to get in the way of your measurement of T. So these two variables, sigma and r, should be your variables that are kept constant. Okay. So a lot of times when you want to find the variables to be kept constant, it will usually be readily apparent from your equation given. Okay. But if let's just say your particular question is a bit weird, you cannot really identify any variables that should be kept constant inside your experiment, then you have to kind of think something out. There's some other variables that you have to think some other variables out. Okay. Inside the equation. All right. So this one usually does happen occasionally, but usually what we'll say is that it's normally readily apparent from your given equation. All right. Now for variables to be kept constant, we would normally suggest that you give at least two. Okay. Because variables to be kept constant, there are quite a number of times where they actually give 2 marks for variables to be kept constant. So you have to have at least two. All right. But under some very rare cases, there are 1 or 2 instances so far where they have no variables to be kept constant. Okay. But most of the time, you always have some variables to be kept constant. And usually you need to give 2. Okay.
Okay.
Right. So this is that. And next one will be how you want to set up your experiment. Okay, now, because you see, as I mentioned to you, your question 1 and question 2, you only have 1 hour and 15 minutes to do question 1 and question 2. So you look at it, right now 75 minutes divided by 2, you only have 37.5 minutes to do each question. All right, so time is actually quite short when it comes to paper 5. All right, you cannot afford to like dilly-dally around. Okay, so when it comes to the diagram setup, you have marks allocated for diagram setup also. But the thing is that what I'll also mention to you is that when you try to draw your diagram, I would suggest that you try to draw a rough hand sketch first of your apparatus setup and then start writing your answers. Okay. Now diagram setup usually only would give you about maybe 2 to 4 points. Okay. Depending on the question, what is it asking. Diagram itself is actually worth 2 or 4 points. But when you draw this, I would suggest you just draw a rough hand sketch will do. Then start writing your answers. It's only once all your points are written, then if you have time and you have time remaining, you redraw your diagram properly. Because a lot of times what happens also to most people is that when they first do the diagram, and then they start writing their answer, point number 1, point number 2, point number 3, and so on and so forth, it will somehow occur along the way to them that there are actually some other better ways to do the experiment, some other adjustments that they can do to the experiment. So if let's just say, for example, they really draw the diagram here in the first place, and it took them, like, say, 5 minutes to draw properly, and then somehow around the time when they wrote point number 7, and they realized that, yeah, my diagram is actually not really accurate, not really good, it will be a case where you go back and then you rub off everything and then you redraw your diagram properly again. So this one actually kind of wastes time. So it's better to draw a hand sketch first, so that in the case where you somehow backtrack, it is very easily salvageable. You can actually repair back whatever you have because you haven't drawn it out properly yet. Okay?
Yep.
Yeah, so that's the thing that I just mentioned first. All right. Okay. Then after that, when it comes to your actual points writing, you don't need to write your answers in the form of an essay. You usually just need to
Point
write
form, right?
point form. Yes, 1, 2, 3, 4, 5, 6, etc. Okay, just write it in point form. So some of the things that we normally would ask you to write for the points would be, remember just now we identify the independent, the dependent, and constant variables.
Mm-hmm.
A lot of times the marking scheme will allocate marks for you describing how are you actually going to measure the independent, dependent, and constant variables. Okay, how you measure them experimentally. Okay, and in some very rare instances, especially for the older past years, the very, very old ones, they will actually allocate marks for you describing how do you actually vary your independent variables. This one is actually more for older past year questions. But the more recent ones, normally they don't really bother about this anymore. It's more like something like this now. For example, if again I want to do an experiment to measure the force versus force and extension of a spring that is given a load, you mentioned before that the force is my independent, correct?
Yeah.
Force is my independent, X is actually my
Dependent.
dependent. So in this context here, if it is a P5 question, how will you vary your independent variable? This one will actually be achieved by you actually adding slotted masses to your load hanger.
Oh, okay.
Yeah, that is what we mean by how actually are you going to vary the independent variable. We know you want to change the mass, but how are you going to actually achieve it? So you use different slotted masses placed on a load hanger. Okay, that's what I meant. All right.
Yeah.
So that one is okay. And then the next 2 points will be you explaining to us what graph should be plotted, what relationship is expected, and what's the expression for the constant. Now, these 3 points here is actually something that you would have done before the start of your experiment. Remember just now I mentioned to you, once you read your question, you first identify what is independent, dependent, and then try to make it into a y equals to mx graph, y equals to mx plus c graph. From there, you actually already know these points. What graph to be plotted, what relationship is expected, and then how are you going to find the constant. Okay, so this one would actually be this tree here. Okay, yeah. And then one thing I should probably mention to you here is this. There's something but very particular about how you find the expression for your constants. This is something that the marking scheme are very particular about. Always make sure that you make your constant the subject. Okay, what do I actually mean by that? If you kind of look back at this little diagram here, so not the diagram, you look back at the first page on my writings that I did here, I mentioned to you earlier that gradient is actually 4 pi over sigma k r squared. The question wants you to find the value for k. All right. Now, if let's just say you write in your workings, your answers, you say k can be found from gradient equals to 4 pi over kr square, the marking scheme actually will not allocate you any marks for saying this. Because what the examiner's report like say is that they want you to make the
K the subject.
K the subject. So you have to actually kind of write in your answer, K is actually going to be 4 pi over sigma r squared times the gradient. If you write it like this, then they accept. But if you write it as the first line, they will never accept. Okay, it's just
Okay.
something quite particular about the marking scheme. Alright, so just remember that. Okay, so then this one, okay. Some other things that you then further write will be number one, your safety precautions. Okay. So safety precautions, we generally only need 1 point. Unlike variables to be kept constant, we need 2 points. So safety precaution is only 1 point. Now for safety precautions, the way you word your safety precautions, in general, we suggest that you explain what your safety precaution is actually protecting against. Let's just say, for example, I go back to the example of your mass on the spring, which you apply a load. Okay, so what possible safety precautions should you practice when you're dealing with an experiment concerning loads? Okay, when you're trying to measure the extension of a spring by applying a load onto the spring, there is the danger of the
It
load
falling.
falling, right? So
Yeah.
it will fall and probably hit a person's leg, right?
Yeah.
It could fall and then go and shatter the floor, right? If it's made of,
Yeah.
all right. So like in your case now, if I wanted to somehow state a safety precautions relating to the experiment, if let's just say, for example, you are afraid of the falling load, falling on your foot, if you just say, oh, wear safety boots or wear lab shoes,
You won't get the mark.
that one you won't get the mark because you're
Yes.
actually not saying what is it supposed
Protecting.
what is it supposed to protect again. If you say you wear lab shoes to protect feet from falling load, that one would be correct. That one will give you your marks. And then let's just say you're talking about protecting against the load falling onto the floor. You just say or use sand tray, that one will not be getting any marks because you're not explaining what is it supposed to be doing. Why do you need the sand tray for? But you say use sand tray to catch any falling load, then that one will be a valid safety precaution. So this is what I
Okay.
meant. You need to kind of describe more what is it actually preventing or protecting against. Okay. Right, so that one should be okay. Okay, now then after that, once you have those first 9 basic things patterned out, there will be some other additional details that you will need to write in your question, in your answer, sorry. So generally, additional details that will net you some other extra marks would be number 1, how you actually improve the accuracy and reduce the error in your experiment. So again, I go back to the example of a mass on a spring, okay, mass on a spring whose extension you're trying to measure after you apply a load. Now, how will you improve the accuracy of your experiment? You could probably say, like in your case, you mount a ruler vertically next to your spring and then you place a pin pointer to act as pointer. You place a pin next to the, you attach a pin to the spring so that you can easily read the reading on your ruler. So this one would be like how to improve the accuracy of your measurements. Because you know you want to measure extension, but how are you going to improve the accuracy of your extension measurement? So you say something like, I go and place a pin on the spring so that it's easier for me to read the scale on the ruler. So this is improving the accuracy. Then how about if you want to reduce the errors inside your readings? You probably would say that for each F you repeat experiment a few times and take average X. This is what we mean by kind of like reducing error. Reducing error is
Okay.
reducing error is actually kind of like improving accuracy. So these are actually the same thing, all right? Okay, right. So that's what I meant. Okay, then also when you do your questions, you will eventually realize that you can actually describe other measurements to be taken other than the ones that is given by the equation. As you go along doing your questions, you will notice that there are certain variables that cannot be measured directly. Take for example, if my equation, this one doesn't have anything. Take for example, like this one is a different question. This is actually the November 20 P51. If let's just say you see your given equation here, there's this a here. This a here is actually error. It's actually the variable to be kept constant. Okay, so in writing your answers, I mentioned you would need to describe how are you going to measure your independent, dependent, and variables to be kept constant. So that in your current case, if I wanted to measure the area is the variable I want to keep constant right now, but I want to describe how I actually measure the area. Is there anything that you know that can just directly measure area?
No.
Nothing, right? So
Yeah.
let's just say this one is something with a circular cross-sectional area.
So I have to do it
Yeah.
manually.
Yes, you have to do it manually. So like in your case,
But
to
then I would have to describe it like in the paper, right? When
yeah,
I'm
you will
writing
have
it.
to describe, okay, I will need to take measurements of the diameter.
Diameter.
Yeah, and then area is actually found from equation pi over 4 d square.
Yeah.
So this is what I actually meant by the part where there are other measurements that may be required. So you have to describe what measurements are supposed to be taken. And then after that, you also have to tell us how would you use what you just measured to find out the variable you're trying to find. Like in my case, I know I want to measure area. So I need to measure diameter. Then from there, how am I going to get the area? So I have to kind of explain, I'm going to use this equation. Okay?
Okay.
It's actually what we are supposed to do. Usually these are the few easy points to score lah. Okay, right. Then after that, last but not least, sometimes the other additional detail could also come from you telling us how are you going to make your measured value bigger if applicable. It's like this now. If again I go back to the case of mass on the spring, if you go and do your experiment in such a way that your extension is like 1 millimeter, 3 millimeter, 5 millimeter, this is very small, right? Wouldn't
Yeah.
your experiment be more accurate if you do it in such a way that you get 1 centimeter extension, 3 centimeter, 5 centimeter? So
Yeah.
if you do it this way, your experiment will actually be more accurate. Okay, this is what we mean by making your measured value bigger, as applicable, as if it's applicable to your question. Okay, so these are the few basic points to notes when it comes to your question one. So as long as you know this format and you try to answer your questions based on this format, minimum you will be able to get at least 7 points. Okay, because when you look at it right now, the formatting, identifying independent and dependent variable as well as variable to be kept constant is fairly straightforward. This one, even if you do not know how to conduct the experiment, you by right should be able to just see from the equation as well as what they describe to you. Okay, so this one will give you maybe about 2 to 3 points. Then after that, if you look at the given equation and then you tell us what graph should be plotted, what relationship expected, what are the expressions for the constants, this is another 3 points here. Okay, so these 3 points is more or less guaranteed already. Okay, if you're in the right state of mind doing the exam, this 6 points or 7 points is really more or less guaranteed. So the rest of it will be more on you just writing whatever comes to mind, like drawing a diagram, explaining a little how you measure the independent, dependent, and constant variables, telling us what is your safety precaution, and then giving us some other additional detail. So it's actually very much possible to score at least half on your paper, okay, for question one. All right. So this is the basics of it. Okay. So let's have a look at your actual question. This is March 2021 P52. Okay, so this is how you would do the experiment based on the format that I just mentioned. Would you rather I just go through the point one by one for you before you copy, or you copy first before I go through it?
I think go through it first because I already tried doing the question.
Oh, okay, that's good. All right. So in your case, you see how you word your answers. Usually, you start off with independent variable is mass m of the cylinder. Dependent variable is period t of the oscillation of the cylinder. The variables and their description, actually, you can easily just get it from your question description. Okay.
Mhm.
Then variables to be kept constant will be the radius r of your cylinder and density sigma of your cylinder. Okay, so this one. Now, there's one thing that they are very particular about when it comes to variables to be kept constant. Okay,
Okay.
because for some people, variables to be kept constant, they somehow equate it to be variables to be manipulated.
Oh,
Okay, because you manipulate it to be constant. Okay, that's why the marking scheme, specifically the examiner's report, has actually made a note on that. Candidates are really supposed to write variables to be kept constant. This one is the proper term to use. But if you say it is variable to be manipulated, this one is actually wrong. Because some understanding for students is that another term also they say is this, variable to be controlled. Okay, these two terms. You say your variables to be kept constant is variable to be manipulated, variables to be controlled, these are wrong terms to use. You just
okay.
have to say is variable to be kept constant. Okay, because this one I think is the one that comes up most often. They say they see a lot of answers from candidates saying that variables to be controlled are these variables here, because for them you control them to be constant or you manipulate it to be constant. So that's not the correct term. Okay, right. So this one is okay. This is you identifying the variables, independent, dependent, and variables to be kept constant. So the next one that you normally do then is to kind of like explain how are you going to measure all those variables. Now, say for example, you want to measure your mass m, you will say, oh, I just use a top m balance to measure the mass. Okay.
Yeah.
Then after that, like in my case here, I actually don't need to say how I vary the m because question already mentioned. Because like I mentioned to you, in some cases, especially the older past years, they will ask you how you actually vary your independent variable. But in your case, it doesn't apply here because the question has already said how are they going to change the mass. Okay.
Okay.
All right. So then next comes the part where you explain how are you going to measure the period of oscillation of the cylinder. Okay. So describing how you measure the period of oscillation of the cylinder, it's not as simple as just saying use stopwatch to measure the period. So there are other things that you can describe in detail. Let's say, for example, this one actually kind of like combines everything together, how you measure your period and additional details to it, how you improve your accuracy, how you reduce your error. So like in my case, I will actually say that when I want to measure the oscillation, I will use a video camera with timer and slow motion playback to time the oscillations. I measure the time taken t for n number of oscillations where n is at least 5 times. And then I use equation t is equals to small t divided by n. So this is already you kind of describing how you measure period in the first place. But then after that, you could also kind of go one step further in describing how you make your period measurement even more accurate. So how you make your measurements even more accurate, that one is actually point A here and point C and point D. All these are improvements that you can make in order to make your experiment more accurate. You go and make sure your measurement, your timing is done over a large number of oscillations. You repeat experiment for each M and determine average T. You mark on beaker a reference point for the oscillation, then replay the video frame by frame to determine start and end of oscillations. Okay. Yeah, specifically part C is the one that I want to kind of mention to you. Now, the part where you say repeat experiment and find average, this point, more or less nowadays, is almost always a point that is present in your paper 5. Okay. But there's a certain way to word this point. I mean, if you just say, for example, repeat experiment and determine average. If you had written your answers like this, where you just say repeat experiment and determine average, this again does not carry any marks because this one is too generic. It's too general. Okay.
Yes.
So you kind of need to specifically state how are you going to repeat your experiment? What is it that you actually repeat it for? Like in my case, is worded in such a way that I always say this: repeat experiment for each M and then determine average T. This one could be kind of generalized as repeat experiment for each of the independent variable and then determine the average of the dependent variable. Okay, this one is the generalized form. It's always written in this manner. Repeat experiment for each of that variable and then determine the average of the other variable. If you write it as that, then usually this is a point that will be given a mark. Okay, it's a point that for me, I will always write out regardless of whether it's in the marking scheme or not, because I see it almost always is inside nowadays. Okay, right. So that one is okay. All right. Then after that, we go to the part where we talk about the variables that are supposed to be kept constant. Okay, now for the variables that are supposed to be kept constant, we know we have radius r. But you see, radius r is not something that we can measure directly when it concerns a cylinder. We actually have to use we actually have to measure the diameter first before we can actually get the radius, where the radius is actually d over 2. Okay, so here we actually kind of describe it as use a micrometer or caliper to determine the diameter, and then to determine r, use equation r equals to d over 2. You see, this one alone is the 1 point, 1 point. Just by you describing further how you're going to measure the variables that you're trying to keep constant. Okay, now from there you can actually also say something specifically when it comes to diameter measurements. There's always this point that can also be used where you always say this: repeat the measurements of diameter in different directions and take the average. Okay, because you're measuring diameter, the diameter is known to be somewhat inaccurate if you always measure it one time, so you need to kind of like measure it a few times. Okay, repeat measurements of diameter in different directions and then take the average.
This is again for accuracy, right?
Yeah, this is again for your accuracy. It falls under additional details now. Okay, it falls under additional details. Okay.
Yeah.
So as you do a few more past years, eventually you notice that there's a certain pattern. There will always be certain associated points for certain measurements. Let's just say diameter, there's always a few points you can say. Then for density, there's always a few points you can say. For period measurement, there's always some associated points you can say. Okay, right. Okay, then after that, you look at the other few points remaining. I'll just clear this one. So this one, the next few points, point number 9, 10, 11, plot a graph of t squared against m. Relationship is valid if a straight line graph passing through the origin is produced. My gradient is this, but make the constant the subject. I'll get k equals to 4 pi over gradient sigma r squared. Okay, so this one is actually 3 points itself. Right? This one is already in their own way 3 points. Okay. So from there you will have your safety precautions. Okay. Because the thing that you're dealing with is actually oscillation of your cylinder inside oil, you actually can say certain precautions to it. You can say that you perform the experiment inside a tray in order to prevent oil spillage, or you use gloves to prevent oil from contacting your skin or to prevent your hand from becoming slippery. These are your safety precautions. Only one is required. All right. Okay, then another thing here just now was that I only described to you how I'm going to measure R, right? I never described to you how I'm going to measure the density. So measuring the density, telling us how you measure the density of the oil is another point where you can score. So if I wanted to determine density, I would need to measure the mass of the oil using a top band balance, where mass of oil is actually the mass of beaker plus oil minus mass of beaker. Then I measure the volume of oil using a measuring cylinder, and finally use equation density equals to mass over volume, where in this case is adapted to the variables that I have. Sigma equals to m of oil divided by volume of oil. So this again is something like your additional details where you can score. All right. And then last one is also something like additional details. Wait for oscillations to become steady or even before timing your oscillations. Okay.
Okay.
Right. So these are basically all those things. And then your diagram is basically this. All right. This is the properly drawn diagram. I mean, let's just say you want to draw a diagram like this in the exam. This one probably will take close to 5 minutes. If anything, usually if people try to draw the diagram properly, diagram is the one that kind of takes a lot of unnecessary time, at least 5 minutes and above. So that's why I mentioned diagram should be drawn last properly. The diagram should be drawn properly last after you have finished your points. Okay. Right.
Yep.
So that should be it.